The question we are solving now belongs to test series 9. It is of signals and systems subject. In specific, it belongs to jet transforms. As per the question, the system function of a LTI system is given as h of z is equal to 1 minus 2z inverse divided by 1 minus 1 by 3 z inverse. We need to pick the correct option as related to this system. As per option A, if system is causal, then it is unstable. We know that ROC of a system is bounded by poles and should not contain any poles. From this we can say that the possible ROCs are mod z greater than 1 by 3 and mod z less than 1 by 3. And also if the system is causal, ROC should be outside a circle. So mod z greater than 1 by 3 is the correct ROC if the system is causal. And we see that this includes unit circle. So we can say that the system is stable. So if the system is causal, the system is stable. Hence the option A is not correct. Now let us consider the option B. As per option B, the impulse response of this system controls this LTI system is imaginary. We know that if the system function h of z contains real zeros and poles and conjugate zeros and poles, the impulse response of this system will be real. And we see that in the current situation, the 0 is located at 2, which is real, and pole is located at 1 by 3, which is also real. From this, we can say that the impulse response of the system is real. Hence, the option B is also not correct. As per option C, mod z greater than 2 is the possible ROC of the system. From the given h of z, we see that the possible ROCs are mod z less than 1 by 3 and mod z greater than 1 by 3, as ROC should be bounded by poles and should not contain any poles. Hence, option C is also not correct. Now, as per option D, it is given that if system is causal, the difference equation y of n minus 1 by 2 y of n minus 1 equal to 1 by 3 y of n minus 1 equal to x of n minus 2 times x of n minus 1 represents the system. So as the system is causal, we can write h of z as y of z divided by x of z is equal to 1 minus 2z inverse divided by 1 minus 1 by 3 z inverse. Upon cross multiplying these terms and upon taking the inverse z transform, we see that we can write the difference LCCDE as y of n minus 1 by 3 times y of n minus 1 is equal to x of n minus 2 times x of n minus 1. From this we see that the LCCDE given in the option D represents the given LTI system if the system is causal. Hence option D is correct. So the correct option out of the given options is D.